Hello learners, welcome to your favorite e-learning platform Pathshala. I am Savita Chauhan, your mathematics mentor. Let's just start today with a new chapter, and that is nothing but the polynomials. So what are polynomials? So let us suppose I am talking about the polynomials in a mathematical language. So these are nothing but some expressions which are either of the form either this, or we can say this or this. So we can see from these particular expressions that they do consist of some algebraic expressions which do have some variables, that is x and y or z within, and do have some constants. So this is nothing but the mathematical language of the polynomials. But is the polynomial or the polynomial is only about these expressions? No. Polynomials can be visualized in an interesting manner. So let us suppose I am talking about the real life application of the polynomial. Have you ever seen a roller coaster ride? Obviously, we all do have an experience of a roller coaster ride. So a roller coaster designer always, before planning the ride, they use the polynomial functions in order to plan the steep rises and the stomach churning drops. So this is nothing but a real life application of the polynomial, because polynomials do play an interesting and an important role in planning the rides of a roller coaster. So isn't it interesting? Now let's just move on further and talk about the visualization of the polynomial function. As we know about an algebraic identity, which is a plus b whole square, which is a square plus 2ab plus of b square. So this is also a polynomial, and we can visualize it rather than learning it as, let us suppose I am talking about a square having the side as a and a. So the area of this particular square would be a square. And further, let us suppose I am extending both of these sides in the upward as well as on this direction as b. It means that we have now two rectangles, and the area of these two rectangles will be AB and AB again. Why so? Because we know that this is nothing but B and this side would be A. So this area would be AB, because the area of the rectangle is length into breadth. Now let us suppose I am talking about this smaller section. Obviously, this smaller section is nothing but a smaller square which do have a side as B. Hence, the area of this smaller square is nothing but B square. Now, let us suppose I am talking about this whole square, as we know that the whole side or the side of this particular square is nothing but of the form A plus B, because the total side is of the form A plus B, and again this side is also A plus B. So the area of this whole square is A plus B whole square, which is equal to the four sections. What are those four sections? A square, the two rectangles, and the smaller square. So hence A plus B whole square is nothing but is equal to A square plus B square plus of 2AB, because there are two rectangles in it. So isn't it interesting that rather than learning this A plus B whole square is equal to A square plus 2AB plus B square, we can visualize it in an interesting manner. Now let's just move on further and talk about the another algebraic identity, that is A minus B whole square, which is equal to A square minus 2AB plus of b square. Again, let us suppose I am taking this particular square, and now I am subtracting, or I am taking, let us suppose, the side B in this particular square, which do have an area as A square. So I am taking B on this side as well as on that side as well. Now again, let us suppose I am talking about finding out A minus B whole square. So obviously, if this whole side is A, this side is B, so this side would be A minus B. Further again, this side is also will be A minus B, because the whole side is A, this side is b, so the smaller section or this section would be a minus b. Now we have to find out a minus b whole square. Now let us suppose I am talking about finding out this a minus b whole square. It means that we have to subtract the whole area, that is a square, with how many terms or with how many things. So let us suppose I am talking about a minus b whole square. So this is definitely be equal to a square, means the area of the whole square, and subtracting the two rectangles from this, which is of the form AB. So I am talking about this green section AB and this yellow section again AB. So a minus b whole square would be like a square, that is the area of this whole square, minus of the rectangles, this rectangles area, minus the area of this yellow rectangle, but plus b square. Why so? Because this particular section is nothing but a square having the area as b square, and this section is subtracting 2 times, so we have to add it again as plus b square. So hence a minus b whole square is nothing but is equal to a square plus b square minus of 2ab. So this is all about a minus b whole square, which is equal to a square plus b square minus of 2ab. Now let's just move on further and talk about another identity. So as we know, this is b square, the area of this is ab, and further the area of this again is ab. Now let's just talk about a square minus b square, which is equal to a plus b, a minus b. Now again, let us suppose we have this particular square and having the side as a. Again, this would be a. So let us suppose we are talking about the smaller square of this particular section, and it do have a side as b. So this is b square. Now we wanted to find out this white section, which is a square minus b square. So let us suppose I am drawing a particular line in a diagonal area. So let us suppose this is a minus b, this is a minus b, and I am drawing this particular line. So let us suppose I am just talking about this white section only, and I am flipping this particular section. I am flipping this particular section in an interesting manner. So let us suppose I am just taking the white section, and the first white section would be like this, and the second white section would be like this. So let us suppose I am flipping it. I am flipping it and joining it. I am flipping it and joining it, and this whole section that I have joined would be like of the form a plus b and a minus of b. So thus a square minus of b square is the white section over here, and after flipping it and forming it into a new shape or into the new particular figure, so this is nothing but a rectangle, and we do know that the area of the rectangle is length into breadth, and hence a square minus b square is nothing but is equal to the rectangle, which is nothing but a plus b and the multiplication of a minus b. So this is all about visualizing these polynomials in a beautiful manner. I hope this is all clear to you, that how we can visualize or how we can picturize the polynomials in an interesting manner in our real life. Now let's just further talk about the word polynomial. What is a polynomial? What is the meaning of the word polynomial? So actually polynomial derives from 2 words, that is poly and nomial. The meaning of poly is nothing but many, and the meaning of nomial is nothing but terms. So polynomial is a combined term which says or which is all about many terms. So here we are talking about many terms which are joining all together with some mathematical operation. So the meaning of the word polynomial is nothing but many terms. Now let's just move on further. So let us suppose we are talking about what are polynomials now. As we have discussed about the polynomials in the most interesting manner, relating it with the real life application or visualizing it with the help of the algebraic identity. But now we are talking about the mathematical definition or a proper definition that what are polynomials. So the expressions which contains one or more terms with non-zero coefficient is called a polynomial. So what are polynomial? These are some kind of an expressions which contain one or more terms. They do have one term or more term with non-zero coefficients, and thus they are called as polynomials. So for example, let us suppose I'm talking about minus a plus b or either x plus y plus z. They are all polynomials because the expressions which do have one term or more terms with the non-zero coefficient, they are called as polynomial. So these are nothing but the examples of the polynomials. Now let us suppose we are talking about this particular expression. We have 2x cube plus x square minus x plus 1. So as per the definition, this is nothing but a polynomial, but polynomial do have many terms in between, or we can say there are many topics inside the particular term polynomial. What is that? So let us suppose I am talking about the spaces that do exist in this particular polynomial. How many spaces are there in this polynomial? So the spaces meaning how many number of mathematical operations are there. So as we know, there is plus, minus and plus. There are three signs. So let us suppose I am calling them as spaces. So let us suppose this is the space number 1, this is the space number 2, and this is nothing but the space number 3. So after spacing, let us suppose I am talking about the words. How many words are there in this particular polynomial? So words are, let us suppose 2x cube is my first word, x square is my second word, x is my third word, and 1 is my fourth word. So actually these words are separated by these spaces, and spaces are nothing but called as the operations, the basic mathematical operations. So at the end, what we have concluded from this particular definition or from this particular example is that any particular polynomial do have some spaces which are nothing but called as the mathematical operations or the basic mathematical operations, and they do have some words, and the words are actually called as nothing but terms. So what we can say in this particular polynomial, that how many terms are there in this particular polynomial? So there are 4 terms in this polynomial, and they are all separated by 3 spaces or 3 basic mathematical operation, that is plus, minus and plus. So this is all about the very first concept in which many a times question would be of the form like how many terms are there in the following polynomials. So using this method, you can find out how many number of terms are there in any particular polynomial. Always remember, the spaces are representing the basic mathematical operations, and the words are nothing but representing the terms over here, which are of the form 2x cube, x square, x and the constant 1. So words are representing terms and spaces are representing the mathematical operations, either plus, either minus. So this is about the term or the very important or a special term which is nothing but called as terms, that how many number of terms are there in this particular polynomial. So in this particular polynomial there are 4 terms, all of them are separated by the 3 mathematical operations. Now let's just move on further. Let us suppose we are talking about further what are polynomials, and we are taking the example again of 2x cube plus x square minus x plus of 1, and here let us suppose I am taking the very first term which is 2x cube. So I am taking 2x cube over here. So they do have their own specifications, means 2 is nothing but called as a coefficient. 2 is nothing but called as a coefficient, x is nothing but called as a variable, and 3 is nothing but called as a power or exponent. So it means in a polynomial, there are some of the terms which are called as the coefficient, variable, power, or we can say the exponent. So let us suppose I am talking about 2x cube. So in the 2x cube, 2 is nothing but called as the coefficient, x is nothing but called as a variable, and the power is nothing but called as the exponent. So let us suppose I am talking about taking this term as x square. In x square, the coefficient of x square is nothing but 1, variable is x, and the power is nothing but 2. Let us suppose I am talking about this minus of x. In this minus of x, the coefficient is minus 1, variable is 1, and the power is nothing but 1. So this is all about the terms. What is the meaning of coefficient, what is a variable, and what is a power, or we can say the exponents. Now let's just talk about the conditions over 2x cube. So we do know that 2 is called as the coefficient, x is called as the variable, and 3 is called as the power or exponent. So there are some conditions on the variable, on the coefficient, or on the power. So let us suppose first of all we are talking about the conditions for the coefficient. What are the conditions that do exist on the coefficients? That coefficients can be any real number. Coefficients can be any real number. They can be of the form of rational, they can be of the form of irrational, they can be natural number, whole number, integers, they can be anything. Let's just talk about the condition for the variables. Condition for the variables is no limit on the number of variables. So in a particular polynomial, it is not mandatory that there should be only one variable. There can be 1, there can be 2, there can be 3, there can be more than that. So no limit on the number of variables. Further, there is a condition for the exponents, for the powers. What is that condition? That whole number always. Powers or the exponents can only be of the form of whole number. They cannot be of the form of integers. They cannot be of the form of the formation of p by q. So they can always be a whole number. They can always be of the form whole number. So we can say that they can be a whole number only. They can be 0, they can be 1, 2, 3, 4, and so goes on. So these are the three conditions that do exist on the coefficients, variables, and exponents. So these are really very important conditions. We always have to remember these three conditions that do exist on the coefficient, on the variable, and on the power. Now let's just move on further and talk about what is the polynomials in one variable. Polynomials in one variable, as it is clear from the definition that we are talking about the polynomials that do have only one variable in it. So let us suppose we are talking about the definition. It says the expressions which contains only one type of variable in the entire expression is called a polynomial in one variable. So it says any expression which do have only one type of variable in it, such type of an expressions is called as the polynomials in one variable. So for example, we are talking about 3x, we are talking about y square plus 3y. Obviously, in the first expression, we do have only one variable in it, we do have only one variable. So any type of the expressions that do have only one variable in the entire expression, such type of polynomials are called as polynomials in one variable. As we do know that there is no such conditions on the polynomial, means on the variables of the polynomial, as the variables, they do not have any limit, there can be any number of variables, but the definition for the polynomials in one variable says that there should be one variable in the entire expression. Such type of the expressions are called as the polynomials in one variable. Now let's just move on further and let's